So the next 3 podcasts are going to be describing the 3 types of graphs you're going to get. Okay, that's what's really cool about this. You're going to have 3 types of graphs, and you got to be able to recognize each 3. And the way you can determine that is based on the types of asymptotes you have. Case in point, look at this question. Again, non-permissible values, you got to factor. Minus x minus 6. This becomes x minus 3, x plus 2. The non-permissible values, of course, is x cannot equal to 3 and minus 2. If you graph this, you know that this is minus 2 right here. There's 3, 1, 2, 3 right here. There's their non-permissible values, which are going to give you this. And I'm going to do a real quick sketch of this. You know the original graph looked like it was probably coming down like this, down to here somewhere, and then up to here like that. Perfect. Okay, so what does the graph now, the reciprocal, possibly look like? Okay, invariant point, invariant point. So it's going to go through here, up like this. There's the other invariant point through here, and bending here. The other invariant points are here and here. You know that this is going to be somewhere around here because it's reciprocated, right smack in the middle. And look at this. There's what your graphs are going to look like. Oh, make that invariant point bigger. There we go. And that's what your original graph is going to look like. That's one possibility. Okay, so that's very important to understand that that is based on the fact that you have 2 asymptotes. Now, check out the next one that we're going to do right there. Look at this. Now I want to look at this again and say, okay, let's figure out the non-permissible values. The non-permissible values of this, of course, are, well, guess what? You probably recognize this already as a perfect square. X minus 3, x minus 3. So if you think about it, the non-permissible value is going to happen when x equals to 3. Well, wait a second. At 3, 1, 2, 3 means that this guy is not actually, wait a second. This guy is actually going to look like the original graph is going to look like something like this, right? That's what the original graph is going to look like. Well, you'll have nothing down here then. That's really weird. You know and I know the non-permissible value then has to go right through here. There's your asymptote. Well, what do we say when we have a graph that is in this section? Well, yeah, okay, here's our right invariant point. We come up to here then, we come down through here, through the invariant point and go that way. But here's the other invariant point over here. So we'll go again up through that invariant point. If you look at this, since none of the graph, the original graph, since none of this original graph was, if you think about it, none of it was below the 0. Everything was up here to begin with. So guess what? Even when we reciprocate it, there's going to be nothing down here. The entire reciprocated graph is going to be up here. Isn't that interesting? Well, then that brings us to our next possible one. So this had from 2 asymptotes to 1 asymptote. So what do you think the next one's going to be? The next one's going to be, of course, one that does not have an asymptote at all. Huh? This is going to be no asymptotes. Check it out. Can this have a non-permissible value? Look at this. 3x squared plus 9 cannot equal to 0. 3x squared cannot equal to negative 9. Divide each side by 3. Divide each side by 3. You've got x squared cannot equal to negative 3. Of course it can't equal to negative 3. It's impossible for a square root or a squared to deal with this negative 3 here. So how do we go about doing this question? Well, here's the hint. You're going to do this one on your calculator. You're going to set your y max to be 1, your y min to be minus 1. And we're going to plot this, and we're going to see what does this in fact give us. So let's get this calculator going here. And I'm going to put my y max and my y min as 1 and minus 1. So I'm going to go my window setting. Going to go down to my y min. There it is. I'm going to put that as minus 1. I'm going to put my y max as 1. Okay? And there's a reason for this, and you'll see it as soon as I graph this. Go back to this now and go 1 over 3x squared plus 9. Here we go. Y equals to 1 over bracket 3x squared plus 9. Okay, double check to make sure I did it right. Yep. Okay, graph it. Check this out. Boom. That's it. That's all you're going to get. Well, wait a second. Why? Why does it work out to be this? Let me show you what the original graph would have looked like. If you look here, the original graph, if you think about it, is 3x squared plus 9. Look at this. Y equals to a x minus p squared plus q. So p then, because there is nothing that goes in brackets here, your p must have been 0. So this must be 3x minus 0 squared plus 9. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. There's your vertex way up here. This would have been a graph doing something like this, right? Now think about it. It's all above this. So basically what you're going to do here is you're going to reciprocate that. You've got a vertex here at 0, 9. So you're going to reciprocate that. The reciprocal of this is 1/9, which is a really tiny, tiny little dot here. The reciprocal of these numbers are all huge, so they're going to make them even tinier. So they're going to be very, 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 very close to 0. And then this is just going to go up a little bit and then going to come down to represent the fact that this is your 9, and that in fact is your 1/9. Holy smokes. Take a look at this again. That's why I said set your values at +1 and -1, because that in fact, that vertex is 1/9. Holy smokes. How do you prove that? Well, go second and hit the table and look at this. At 0.11111 is in fact 1/9. So those are the three types of graphs that you're going to encounter. One that has 2 asymptotes, one that has 1 asymptote, and one that has no asymptote at all. I think they're incredibly cool.